have your notes in front of you then, right? Does everybody have a ruler this morning? Okay. Last section we're going to cover, chapter 8 today, is about systems of equations, and I'll talk about what this means here in a little bit. Sorry about that, Christian. There you go. Everybody get a ruler this morning? Did you go in, Candace? Yeah. Excellent. Anybody else need one this morning? Okay. I'm going to put something up here real quickly and see if we can't figure this out. This would be a good problem to think of. Let's just think about this. Here's an example. And you don't have to write this down. Just kind of think about this here a second. All right. Everybody make sure you pop open your eyelids here. Blow the dust out or the cobwebs out. Okay, right up here, guys, here's a situation to think about, okay? It says that you have twice as many dimes as you do quarters. Okay? Twice as many dimes as you do quarters. Everybody with me on that? All right, so if I had 2 quarters, how many dimes would that be? Well, just tell me, if I have 2 quarters, how many dimes do you have? When I read that up there, when it says you have twice as many dimes as you do quarters. Not 5. Guys, if I have 2 quarters, double 2, 4, you would have 4 dimes, right? Make sense? Twice as many dimes as I do quarters. I'm talking about the monetary amount. Yeah. I'm just talking about share. How many of each do I have? Okay, so there's twice as many dimes as I have quarters. It says when I put the dimes and quarters together, the amount of money totals up to what value? What's the amount of money total up to? $3.50. Okay. Now, what we need to do is figure out how many of each do I have. How many dimes, how many quarters do I have? Okay. So, hear me out on this, guys. If I had 1 quarter, how many dimes would I have? 2. 2. What's that total up to? Well, if I had a quarter and 2 dimes in my pocket right now, how much money do I have? How much would I say I have? Got a quarter? That's 25, right? This is 20, so wouldn't that be 45 cents? Is that gonna work? Is that total 350? Doesn't, does it? Okay, so what I'm asking you guys to do is think of a certain quantity of quarters, double the quantity of quarters to the number of dimes so that it totals up to what value here? $3.50. Okay? So you can think of it. Just give you a minute to think about it. Anybody got them yet? Kind of a guess and check thing. Not sure. Let's just keep counting along. If I had 2 quarters, how many dimes would you have? 4, right? let's see, this would be 50 cents, wouldn't it? And this would be 40 cents right here, wouldn't it? Does 50 and 40 total $3.50? Okay, so let's try the next one. How about 3? 3 quarters, and that would make this 6 dimes, wouldn't it? Because you have twice as many dimes as you do quarters. See, 3 quarters is 75 cents, right? Isn't 3 quarters 75 cents, gang? Yay or nay? It is. 6 dimes is how much? Is that my 350 right there? No. Okay, so what's the next logical choice for you?
4 and 8.
So let's go 4 and 8. Let's check, kiddos. All right, so what's the 4 total going to get you? 4 quarters total. That's how much? $1. And then how about your 8 dimes? 80 cents, right, kids? Is that going to get you to your 350? Okay. How about 5? 5 and 10. Okay. Let's just change this to 250. Nothing that's totaled up 250. All right. You get the idea of what's going on here. We'll change it to 250. Check this out. What's 5? I'm sorry. Back that up. What's 5 times a quarter going to get you? I put the wrong number in. What's 5 quarters going to add up to? $1.25. What's 10 dimes going to add up to?
Teachers, please release the students going on the mud field trip. Teachers, please release those going on the mud field trip this morning.
What's a mud field trip?
Mud advertising. They must be going up there. Oh, are they going to?
Is that
Japan
something
and
that
collect
the
all
Night
this
Talks
mud?
thing has been, or?
Well, I know they had mud advertising come talk to them that
Did
one
they?
day, so they must be taking a group up there.
Cool.
I didn't know.
Cool, cool. I'm gonna change this total completely. Let's make this work now. Let's change this total to say maybe it said 225. Okay, let's say maybe 225 was the total. What does 5 quarters equal? You said $1.25, is that right?
Yeah.
Okay. What's 10 dimes equal? $1. Would $1.25 and $1 add up to 225? Okay, now I could have kept going and going and going until we got that 350 point. But what I would say right here is, hey, in order for something like this to work, if we stopped at 225, let's just pretend the question said 225 in the beginning. If it said 225 in the beginning, kids, how many quarters and dimes would you have? You would say you have 5 quarters and what? 10 dimes. Okay. Now there's a lot of guessing and checking going on there, right? How many solutions are there to a problem like this? We had to answer for the number of what first? Quarters. And we had to answer for the number of dimes. Okay. This is called a system of equations. Basically, here's one described situation that they give you right here. They say that you have twice as many dimes as you do quarters, right? You have twice as many dimes as you do quarters. That's one set. Then they say, hey, secondly, in this case you have, we change the total to 225. They say those coins total up to what value there? What did we underline last there? $2.25. Okay. How many kind of descriptions did they give you? In other words, this is one set right here. You know you've got twice as many dimes as quarters. Isn't that one part of the description up here? Then it also says that you have.
Grant Hill, please come down to the office. Grant Hill, please come to the office.
It also says that you have $2.25 total, right? So there's like 2 conditions being met here, aren't there? Okay. What we're going to start looking at here today is an example that works much like this. And what we call this section here in 8.8 is systems of equations, systems of linear equations. Who's got a, why don't you guys jump into decimals real quickly, okay? How many quarters did we get? We say 5, is that right?
Yeah.
How many dimes did we have? 10. 5 and 10, right? So check out my decimals here. Does everybody have their Chromebook? I'd say if you don't, just hop in with somebody. Yes, sir. There's a box right up here that I've got if you want to use these. Okay, are you guys there with me? Okay, here's what I'm going to do. I'm going to go ahead and assign some stuff here. I'm going to type up some stuff here. You don't need to write this down, but just watch what I do. Okay. Said that we had twice as many dimes as we did quarters, right, gang? Okay. Now, we didn't know how much of each we had in the beginning, did we? So up here I might say let x equal the number of quarters. Whoops. Did I spell that correctly?
Yes.
What do you think we're going to let y equal?
The number of dimes.
Okay, we said we had twice as many dimes as we did quarters, right? What were we doing to our quarters, the number of quarters we had all the time to get our number of dimes? If I had 4 quarters, we doubled that to 8. So to figure out the number of dimes I had, which is represented by which variable? Y. We had to take the number of quarters and multiply it by what? 2. Isn't that what this statement is really saying? The number of dimes, y, right here, is equal to 2 times the number of quarters and x that you have. You guys agree with that right there? All right. Now, here's the deal. We said the total of each amount then was in this case we'll use 225. Okay. So here's the deal. Up here we have x quarters, right? What's each quarter worth monetarily? How many cents? How much again?
25.
So what I'm going to do is I'm going to set this up. I'm going to say we got 0.25 times the number of quarters that I have. Okay? Right here. Doesn't x represent the number of quarters again, guys? If I had a number to plug in for the number of quarters, let's say 6, or the 5s, or the 4s, or the 3s that we plugged in, wouldn't I take that times 25 cents to know how much money that was? Like if I had 5 quarters, when you plug 5 in for x, so 5 times a quarter would give you an amount, right? Right?
Yes.
Okay? And then to that we were adding in some dimes, and each dime is worth how much?
10 cents.
So 0.10 times, how many dimes do you have up here, gang? How many dimes do you have up here? Y dimes. Okay? And then this is equal to, what did I say that total was in the very end?
$2.25.
Okay, so here's what we're going to do. We're going to look at what this looks like in decimals and talk about what we got as a solution and how we go about solutions in decimals. And then we're going to use that idea to be able to do this on our own. But guys, what was our solution for this mess?
Solution was 2.
How many quarters did we have?
Oh, we had 10.
5, didn't we?
5 quarters, yes.
And y was equal to 10, which meant that we had 5 quarters and 10 dimes, right? Okay, can you guys remember this part right here? Can you guys remember that part for me? Okay, we're going to type this in. Decimals, what's this look like? Again, well, we first equation was y was equal to 2x, wasn't it, kids? Okay, there's that graph right there. What was the second equation that we had? I believe it was 0.25x plus 0.10y equals 2.25, right? Now, whoops, I don't want 10y, I want 10 cents y there, okay? Kids, I want you to notice something right here. The y equals 2x part right up here talks about saying, hey, I have to take the number of quarters and double it to get the number of dimes here, right? You guys agree with that? And then we said, hey, 25 cents for every quarter I have plus 10 cents for every dime I have is going to total a value of what here? Well, 225, wasn't it?
Yeah.
Okay. Hey, I have a question. How many quarters did we have again? 5. Which variable represented the quarters? X or Y?
X.
The X did, right? X did, X quarters, right?
Why does the writing today?
I think I'm on pen mode. I kind of like it. It's kind of different, kind of neat. I'm feeling kind of frisky today.
The way you said that, Miss Parson, gunny,
Yeah,
gunny.
it's okay.
Nah, it's just funny.
Okay. Hey, I've got another question. How many dimes do we end up with? Which variable represents the number of dimes? How many dimes do we have? You said maybe a solution might be 5, 10. Guys, take a look here. Let's find a point 5, 10. Isn't that right about, oh, here, right 5? Oh my gosh. 5, 10. What's true about the point 5, 10, given those two graphs up there? That's where they do what, Taryn? That's where they meet, right? Okay. We're going to be looking at situations today that they give you two different sets of parameters, and they say, here, you got to satisfy both of these. We're going to take those parameters and put them into some kind of a linear equation. We've been dealing with equations and graphs for a long time now, right? We're going to be able to start looking at solving these types of problems by saying, hey, I can solve this equation when I find the point where the two lines do what? Meet. Okay, so if I say this is the point 5, 10 right here, isn't 5 an x value? What did x represent again?
Quarters.
5 quarters. Isn't 10 a y value right here?
Yes.
What's 10 represent again?
Dimes.
Dimes. Okay. We're going to be looking at how many different equations, guys? Two equations. How many variables in there in each equation? Here's the whole idea today. 2 equations with 2 unknowns is considered to be what we call, what's the title of your notes?
Linear equation systems.
Systems of linear equations. All right, this is the big idea today. We're looking at systems of linear equations. So, let's see if we can't figure some stuff out today. Boom. Systems of linear equations. I want a volunteer to read my goal for me, please.
Graph and solve system of
Okay. So in order to graph and solve systems of linear equations, we need to be able to first of all understand what a system and a linear equation is. Okay? System of linear equations right here. We just said it's how many equations, kids? 2 equations with how many unknowns? In most cases, x and y. We got to find a value of x and we got to find a value of y. Okay? Then we talk about this idea of a solution. Well, what the heck is a solution? Okay? A solution's like an ordered pair. What point did we get that crossed up there? You said 5, what? 10. 5, 10. It's an ordered pair that makes both equations true at the same time. What I want you to write down is this. It's the point. Taryn, you fill in the rest. Point where the two lines do what? Point where two lines meet. Now guys, if I have 2 lines in a plane, the old joke is this. Are all lines going to meet? Are all lines going to meet at a point? Can you think of lines that won't meet at a point? Are there any lines that don't cross?
Yeah, there are
What are they called?
triangles.
Well, triangles meet at a point, don't they? Okay. Parallel lines, we've talked about it before.
Parallel.
Parallel lines. Parallel lines ever to cross?
No.
It's too bad because they have so much in common, right? Parallel lines have so much in common. We've talked about the same slope stuff, right? Parallel lines have so much in common. It's a shame they'll never what? Must be too early in the morning for you guys.
You just heard it too many times.
Heard it too many times. It's kind of lost its luster. Sorry. I'll have to come up with better jokes. Let's see if we can't figure this out. Okay, system of linear equations. First of all, right here. How many equations? 2. How many unknowns? 2. We got to find a point that would make both equations true at the same time. Okay, or satisfy both parameters, like we said. Twice as many dimes as quarters. Or they total 225. Okay, now this doesn't show up the best. I'm going to kind of go onto a different sheet of paper here in a second, but you guys take a look at this right here. There's my XY coordinate plane. Actually, I think I can make this work. All right, gang. First of all, when we graph stuff, stuff is very easy for us to graph when you're in what form? What's this form called again when y is alone?
Oh,
Function form. Function form is the best. Or in our case, a lot of these lines we've been graphing, we said function form, more specifically slope-intercept form, right? So let's take a look at graphing this line. I'll do this one in yellow. Now here's the deal. You might want to make this note right up here. When you solve linear systems here, your graphs from now on, they can't just be good enough. The graphs have to be like Mrs. Miller. They have to be perfect. Okay? And I'm going to mark that down as a victory for me right there, because that was a point scored by Parson. Have to be perfect, just like Mrs. Miller, all right? Graphs have to be, what's the word?
perfect.
Perfect. If you don't do the perfect, then you're not going to get a good answer. Okay? Your graphs must be perfect. Now, I'm not so much going to say use your ruler to do this all the time as much as I'm going to say continue to do your slope. You're going to, what I want you to remember is this: continuous slope today. Do you remember continuous slope? Continuous slope. Keep sloping. Just keep sloping. Just keep sloping. Okay. There's a movie they say
I
just,
hated that movie.
just keep.
Oh.
What's the name of it?
Swimming.
Oh yeah. Okay. Just keep swimming. Dory. Dory.
I hated that movie.
I'm gonna do a little bit of Dory with you today. Just keep sloping.
I hated it.
I love that.
I can't wait till Finding Dory.
Isn't that pretty soon too? Isn't it?
I think it's next year. Except I have a feeling it's gonna be just like Finding Nemo, but
It'll be interesting. There's always new characters that come in. That's why I kind of like stuff like that. It's kind of like all the Toy Story movies. I
yeah.
love
Just as
all
long
those.
as you don't watch Percy Jackson and Steve's Monsters.
I love
That's
that
not
one.
a movie.
Never seen it. All right, hey, first one right here. What's the Y-intercept? What kind of 3 is that? Okay, so we're gonna come down here and we're gonna graph this first line. I'm gonna do this one in, what did I say? I was gonna do that one in green, is that right? So come on down 3 units. Your graph shows up better than mine. Okay? Now, this is what I mean by about being perfect. All right? What is your slope? What is your slope?
1x.
Okay, so your slope. Talk to me in terms of rise over run. If the slope's 1, how are you gonna rise over run in a form of 1?
Rise one.
We're gonna rise
Right.
1 and run 1. So from this intercept, I'm gonna go up 1 and over 1, right there. Now what I want you to do is to continue sloping as much as you can. So I'm gonna, from this point, go up 1 over 1. I'm just gonna keep going up 1 and over 1 and plotting. Okay? You need to do all of these. Now, problem is, I haven't covered the left half of the graph yet. I haven't covered left of the x-axis, but you guys see the pattern down here? Couldn't I come down 1 and left 1 now to stay in line? Keep doing that. Now again, we're looking for a solution here. Which value of x and which value of y is going to make both equations true at the same time?
Wait, I thought you had to go down the road.
Well, I got to stay on a line though, don't I? Because it can't be like a V shape. Slope's positive 1, so if I come down 1, isn't that like a negative 1? And then if you go back to the left 1, isn't that another negative 1? Did you check in if you on this? Okay. Down 1 and left 1, right? Okay, they're both negatives. What's a negative divided by a negative? So it's still at positive 1 slope, right? So going down negative and running a negative divided by negative is still that positive slope that we are seeking here, okay? All right. So you guys okay with the first line? Yes? No? Yes?
Yes.
All right. Now, this is where things get interesting. I'm going to change my color. I'll do this one in red. Guys, right here it says, is there an extra sheet of notes there?
Yes.
Okay. All right. Next one we're going to graph. Watch this right here, guys. I got to check something here. Yeah, this will work. What's the y-intercept on the second one since y is low in that one?
Positive 3.
Positive 3. So I'm going to start up here at 3, right? Everybody agree with the y-intercept on the second line?
Mm-hmm.
Okay, so we're going to figure out our slope to do that line right there. All right, what is my slope?
Down 1.
Down 1 and right 5, isn't it? So if I come down 1 and write 1, 2, 3, 4, 5, what happens right there?
They touch.
They touch, or that's the point where the two lines are actually going to do what?
Cross.
They're going to meet there, aren't they? Aren't those lines going to meet right there? Okay. So in the example we talked about with the dimes and the quarters to start this, we said, hey, I think we can solve these systems of equations by graphing both lines and find a point where the lines do what? Meet. Okay? Guys, what's this coordinate appear to be? How far to the right is it?
5.
5 units to the right. How many units up is it? Looks like 1 and 2, isn't it? Okay, so it looks like to me the solution is in x comma y form. Solution is what comma what?
1, 2, 5.
Yep, you would
5,
go from the
2.
origin, right 5 units and up 2, right? Everybody agree? Everybody agree with what they've got? Okay, so my solution is 5 comma 2. Now I want to show you this why this is true. We're saying x equals 5 and y equals what here? 2. We're saying x equals 5 and y equals 2, right? One thing about your Desmos calculator is it's pretty neat. I think it's pretty dang neat. Why don't you just follow through with me here. I'm going to write the two equations over here on the board. One of them was x minus 3, wasn't it?
Yeah.
And the other one was y equals negative 1/5 x plus 3.
Yeah.
Check this out. Decimals is so cool. For this first one right here, y equals x minus 3. For this first one, y equals x minus 3. What did we say our solution was again, guys? 5 comma how much?
2.
What this is saying is this: plug 5 in for what value? And plug 2 in for y. Watch what you can do right here. This is so cool. I'm just going to plug 2 in for y. I'm going to say 2 equals, what are you going to plug in for x? Based on our solution that we got. 5, right? Guys, look at what I've done here. How was it going to do that? Mrs. Miller, didn't they used to say true before?
What's that?
Didn't we have a true saying there before? I thought we did. I'm pretty sure we did. Remember Brianna in that second hour that one day? Plugged all it in. She's like, Mr. Parsons.
Oh, yes. Yeah.
Did they change that on us? Let's try the next one. What would I plug in for y on the other one? 2 equals negative 1 divided by 5 times 5 plus 3, didn't it?
Wait.
Yeah. 5, so x.
I don't remember what.
Does it do it on your Chromebooks? Check here. Let me check. Probably one over there. You want to go find one? What was it? 81 through 85. Are you guys into Desmos right now?
Yeah.
You guys type in what I type in up there and see if it does it on yours.
Do what?
Type in the 2
I did that.
equals 5 minus 3.
Did I?
You should probably do that one instead of the other one.
Okay.
Yeah, it doesn't do anymore.
It's not doing it anymore?
No, but I can't remember, did she?
Maybe they took that part of it out. Well, I'll tell you what, I'll mess around with it here in a little bit. But we can still look at this right here. That's interesting. I don't know why they would have changed that, because it used to pop up as true or false for us. So I'll look into that and see. But guys, everybody right up here, this first equation, everybody with me? When I punched in y equals x minus 3, guys, does 2 equal 5 minus 3 when I put my solution in?
Yeah.
It does, doesn't it? Guys, take 1/5, negative 1/5 of 5. In other words, 5 divided by negative 5. What is that? Negative 1, isn't it?
Yeah.
Negative 1 plus 3 more, is that a 2?
Yeah.
It works, okay? It works. All right? So, there's that. And, gosh, I'm sorry that didn't work. Should have. I'll look into it, okay? All right, so let's get back to your notes. Big idea today is we're looking for the point where the lines do what?
Cross.
And where they cross. So what's the solution to this? You would say 5, comma 2. All right, so let's look at another example here. I like this example. First of all, notice what's going on here. 2 things. Every time you start these problems, you always want to ask yourself if you're in function form or slope-intercept form. Is y alone in both equations?
Yeah.
Okay. This says solving a linear equation with what here?
With no solution.
With no solution. Let's check out what's going on. What do you notice about the slopes, first of all?
Both the same.
What do we recall about slopes being the same of lines?
That's not supposed to happen.
Are they going to cross or be
They're good.
parallel, aren't they? Okay, check this out. We'll do some colors here. Let's find a solution to this. I'll do the first one in blue. What's the y-intercept here, kids? Negative 2, isn't it? So I would start right here. Guys all agree? Down 2 units?
Yeah.
How about my slope now? How about my slope?
Oh, -3.
Down 3 and...
Over 1.
So I'm going to count out 1, 2, 3, and over 1. And I'm going to do this just once, or am I going to do it a lot of times?
A lot of times.
Because the idea is to be perfect here today, right?
Yeah.
Guys, if I've gone down and right, I should probably go up and back to the left to complete the graph. Would you guys buy that?
Yeah.
Okay.
So you're supposed to go down.
Down 3 and right 1. Yep. For negative 3, I'd be the same as negative 3 over 1, right, Kyle?
Yeah.
Down 3 over 1. Down 3 over 1. Okay, so here I can go up 1, 2, 3, and left 1 to stay in alignment. Up again. Whoops. There we go. Up 3. 1, 2, 3, and left 1. Okay, so that's going to be all the points that I can get on that graph that would make that perfect. Okay, and I might just go ahead and draw a line through that real quickly.
Alright.
All right, draw my line through that real quickly. Okay, you guys agree with that line right there? Everybody agree with that?
Yeah.
Okay, let's graph the next one. Let me choose a different color. Oh, it's crazy today on colors. That one looks kind of pretty. My middle child, Lucy, would appreciate that color. What's the y-intercept on the second graph, kids?
3.
Okay, so positive 3. I'm going to start off 1, 2, 3 units. Okay, how about the slope through that point? How about your slope through that?
It's down 3 over 1.
Down 3. What appears to be happening here? Looks like they're ever going to cross at all? No. Okay, so I'm going to be, okay, so this is the y-intercept. I'm down 3 over 1 for my slope. Down 3 over 1 because that slope is negative 3. Gosh, when I draw my line for this one, it looks to me like the same situation here. Looks to me like these two, oops, didn't want to do that. But I can fix it. I can fix it.
I fix it,
Felix.
Felix Jr.
Fix it, Felix. These two lines appear to be what kind of lines, kids?
Parallel.
Are parallel lines ever going to meet? No. We just got done talking in the last example and said, hey, in order to find a solution to this, we're looking for the point where the lines do what?
Cross.
Is there going to be a solution here?
No.
Why not, Kyle?
Because the lines don't cross.
They don't cross. Yep. Yep. It's kind of like in Ghostbusters. Anybody ever watched Ghostbusters?
I have.
You're not supposed to cross the... There you go.
Unless you're fighting some sort of all-powerful deity.
Exactly.
Then go crazy.
I haven't seen that movie in a
jokes.
I know that.
If you have lines that are parallel, they're never going to cross. Therefore, do they share a point? No. Okay. All right. So we looked at a case where we had one solution, the point where they cross, and we were able to identify that. We looked at something that has no solution because the lines were.
Parallel.
You bet your lines are parallel. Now, there's something here that we haven't discussed yet, and we're going to hit today, but the last example, or example 3, says, hey, let's look at an example where there are not just one, or maybe 0 solutions, but what's example 3 say?
Solve a linear system with many solutions.
Find something where there are many solutions. So take a look at this with me. Oh gosh.
Oh God, why?
Oh gosh.
I mean, why?
Oh gosh.
I mean, more work.
This problem looks kind of goofy. Again, as we progress through these, the first question every single time, is what alone?
Why?
Is y alone?
No.
Oh gosh. You gotta put stuff in function form again? Stuff just doesn't go away, does it? Okay, there's a reason for it. Let's find function form first of all. Is y positive up here?
Yeah.
Positive y, good or bad?
Good.
Let's rewrite the top one. I'll rewrite it in this pretty pink. Where am I going to move this 2x to?
Over.
If I move 2x to the right, it was positive on the left. What's it going to be on the right?
Negative.
So let's do the rewrite on this. The rewrite for this looks like the following. I would say y, it's a positive y alone, right? Equals, the 2x is now what kind of 2x on the right side?
Negative.
And what kind of 4 did you have over here initially?
Positive.
Guys, that first equation, do you like that better?
Yes.
Y is alone, right? Cool that?
Yep.
I'm going to do my work down here at the bottom for the next one. Okay, watch. First of all, ask the question, is y positive? It's a positive 3y, right? So do we need to switch all the signs? No. So we're going to move this negative 6x to the other side. So what kind of 6x will you have on the right side?
Positive.
So to the point here, we would have 3y left alone. Everybody agree?
Yeah.
Won't that be 6x minus 12, kids?
Yeah.
All right. Any questions to that point? Anybody? What do I have to do next to get y alone?
Divide everything by 3.
Divide everything by 3, divide everything by 3, divide everything by 3. What are 3's going to do right here, kids?
Cancel.
So I have y equal, how about the 6 divided by 3? 2x. How about the negative 12 divided by 3?
Minus 4.
So the second equation in function form is, oh, hang on a second. We have a mistake in this. Change this for me real quickly, okay? See this negative 6x that's out here?
Yeah.
And see this positive 3y? We got lots of mistakes in this. Absolutely. That should have been a minus 3y. My mistake. Okay. No, we'll fix it. It's okay. This was, what do we say? Negative. Oh, hang on. We're going to call it negative 6x. It should have been minus 3y. Mallory, will you remember that 4th hour for me?
Yeah, yeah. I wondered when I was.
Yeah, my mistake. Okay, so let's rewrite this again. So, I'm going to blame Canada on this one, okay?
Don't blame Canada. Canada's awesome. We have to blame anything. Blame Turkey. We have to blame it on anything. Blame the country Turkey.
Well, I like Thanksgiving and I like my turkey on Thanksgiving. So.
And Russia.
Okay, let's redo this. Let's redo this. This is what it was originally supposed to be. First of all, is 3y positive or negative? What should I do with all the signs then? Change them first, right? So change this to 6y plus 3y equals positive 12. Okay, we want that y to always be positive. All right. Now let's move that 6y out of there. Okay, let's move that 6y out of there. So we have 3y equals negative 6, negative 6x plus 12, right? So moving the positive 6x to the right would make it negative, right? Okay. I'm leading you astray. I'm making sure everybody's back on the straight and narrow. Everybody on my road right now?
Hold on, I gotta scroll this up.
Mr. Carson, I've got to leave to go pick up a student.
Okay, very good. Kyle, you have a question or just stretching?
Just stretch.
All right, bud. All right, all to that point right there.
Yes.
What are you going to have to divide by now?
Divide by 3.
Okay, let's see what happens this time. This will be better. All right, what are 3's going to do?
Cancel.
Okay, so we have y. What's the negative 6 divided by 3 here? So negative 2x. What's the positive 12 divided by positive 3 right here?
Positive 4.
Okay. When I rewrote the second one to get y alone, guys, what do you notice about your two equations right there after we have them both in function form? They're exactly the same, meaning that if I graph one, you already have the graph of the other, which means that when I graph this, first of all, what is the y-intercept here, guys?
4.
Positive 4. 1, 2, 3, 4. What's the slope through that?
Down 2 over 1.
So if I plot all the points, down 2 over 1, down 2 over 1. Okay, there, I've graphed the first equation. Now if I graph the second one, what's the y-intercept in the second one? 4, right here, right? If I go down 2 and over 1, what's happening here? You're just graphing the same line, aren't you? So all these points that I circled, guys, they're all shared points. So all those points that match up or cross each other are solutions. Am I going to have just one point this time that matches up, or am I going to have many points this time? Many points. So here's the deal. If when you get into function form right here, I could say, you know what, the equations are exactly the same, aren't they? Aren't these two equations the same right here? I think I have my y-intercept at 3. Yeah, it's all right. You know, you get the gist, right? Okay, equations are the same. I'm having a bad morning. This might be the worst morning ever. The equations are the same. What am I going to say then about? I can fix it. I can fix it.
Now, the worst morning ever is hearing on the news that J.K. Rowling has died. That'll be the worst day ever.
How about that, Mason? Happy now? So my equations are the same, right?
That was pretty awesome.
Yeah, J.K. Rowling.
Then what am I going to say about here? How many solutions?
There's many.
Yeah, that'll be the worst ever.
Knock on wood.
Many solutions, right?
Yeah.
Okay. So we've had lines where they do what?
Cross.
Cross. We've had lines, all right, and I should back up. If they cross, it's just one point that they share, right?
Yeah.
I've had lines that are parallel. Will parallel lines ever cross?
No.
Therefore, if you have parallel lines,
No
no solution. What about one line that falls right on top of another line?
Oh, they're the same.
They're the same. So how many solutions here?
Many.
Many solutions. Okay? Many solutions. All right, so let's see what we've got here on the next page. You guys got that down right there? At least have it down? Yeah, I want to get through this today. I'd like to give you some time in class to work a little bit tomorrow on this, to get looking at it. But again, the idea is get Y alone. Form your graph. Determine if you have a solution or not. Okay? All right, let's try a couple here. You know what? Try these on your own. First one right here. Go ahead and see what you get for this one and this one. I'm going to give you about 3 minutes to try those. So go ahead and do that. First one's nice because Y is alone in both. They're both slope-intercept form. So go ahead and give that a shot. Well, job. I'm going to top that off for me in the lounge. You don't have to. Just knock on the door quick.
Just as long as you pay her. Maybe give her $5, $6.
She's taking 628 South Cash this year.
Oh, so she's in debt. So she's in debt. She should take the intro to business class. I have to know that. Hey, Miss Berman.
That's kind of smart for stuff like that. How about a solution on the first one, kiddos? The first solution is I'm not awake. Is that what you're saying, Mason? Baron? That first one for me? Do that for me? Alright, I think that looks pretty good. I'm gonna block those from. Tell me what you're doing, kiddo. Alright guys, hey, let's jump in the first one. I don't know if you may or may not be done. I want to make sure we get through both of these here in the last 8 minutes that we've got left. So go ahead and check it out. Taryn, tell me what you're doing here. Tell me why you may proceed with what's there or why you might change it first, okay?
Okay. Well, start with the Y-intercept
Okay, and you can do that because you're in what form?
function.
Perfect.
And Y is
Guys,
a
have this down. Okay, go ahead. I'll shut up.
Okay. So you start with 3, so you just go.
Okay, so we'll start positive 3 there. Very good. All agree?
Yeah.
Okay.
See, Sarah.
And
Graphs.
then it's actually negative 1x. So you'll go down 1 over 1.
Okay, I just want to do it once. Oops, hang on a second. That looks like my graphs aren't the best, so
That's 2 over.
I think it's 2 over.
What is
Hit
that?
the arrow back button up top, kiddo. Can you reach it? Good stretch.
So right
See,
here?
we're cross-curricular with PE in this group too.
Yeah, it's that one.
Where? Right here?
Yeah.
Yep. Perfect. There you go.
That was
Keep
good.
on going. Keep on going now. You have to kind of guess that next one. It doesn't show up very well. No.
No.
On the x-axis. Right in the middle of those two.
Right here?
Look at your graph paper.
Here.
No.
Here.
Left. In
Here.
the middle. There you go.
Here?
Yes. Up.
Here.
Yes.
Okay,
No.
ignore that dot. Can I just, it's hard on this one.
I know. I know. Here, I'll get you a better graph. Let's do this one. You got your equation. Give me this quickly. much up?
3.
How much up?
You're on 2, Taryn. Oh.
Yeah.
Para por atas
Oh, you want a pen, not a highlight.
That's a highlight.
Taryn, I'm so
Just
sorry
one,
to do this to you.
Taryn, press it. Somebody else do it.
Hit the undo button.
Give us more.
Taryn, you wanna know what the beauty about this is today? We're recording this right now.
Which one is it?
The pen, right below the arrow. The pointer.
Where?
Up, just one up.
That's why I clicked that one. It's a brush.
Give us more.
Alright.
Yeah.
Y para por atas verba y Dios what the.
Okay. 3.
Okay, good start.
Okay, then you go down and over one.
There we go. Okay, and then you wanna continue another direction with those?
Oh, yeah.
Okay, very good. Alright, it might take a little time, but do you guys agree with y equals negative x plus 3 up there, first of all?
Wait, what? Oh, yes.
They're tough, Darren, they're tough. Trust me, I know. Okay,
Okay.
now, change color. Pick a different color.
Do red.
Okay, what's the equation? What's the second equation we're looking to graph here?
Y equals 1 over 3x minus 1.
Proceed.
Okay. So the next one is -1, so.
You guys agree with negative 1 as your y-intercept?
Yes.
Okay, and then carry on, kiddo.
And then up 1 over 3.
Because your slope's 1/3, right? Rise 1, run 3. What just happened, Darren?
It cross,
Okay, so what do you think the solution's gonna look like for this?
cross.
What coordinate is that? Like, first of all, why don't you circle the point that you believe to be your solution? Okay, so in x comma y form, how are you gonna express to me that point as a solution? Look at the green that I have below my magnet, just to your left. We had those two equations up there. Do you see in the parentheses up there that I have?
Over there.
My parentheses say 5
Oh,
comma
yeah.
2, right?
Yeah.
How are you gonna express that point you just circle as a solution?
Oh, you're gonna just count the things.
Okay, so what is that point in x comma y form?
3,
3 comma what?
1, -1,
Here. Did you move up or down from that?
down. Wait.
No. Go from the origin.
Okay. 1, 2, 3.
3, and then you move up or down?
No.
No, so what value would represent?
0.
0. So 3 comma 0. I want you guys to give Taryn a hand for that. She
Yes.
muscled her way through that. Sorry, Taryn. I thought you were gonna fly through it, but you got it, right? Okay. Hey, we're gonna stop there today. We'll pick the rest of this up tomorrow. You know what? Here's the deal.
Verba dos grandes.
Not that one.